Death.
That's right.
Okay, here we go. Okay, so you need some blank paper because you do not have this page in your notes. I know. I messed up on the printing. I'm very sorry. I messed up on the printing. There's one page. Hey, please stop talking. You've had plenty of time to catch up. Thank you. I really messed up on the printing. I missed the first page and it didn't collate, so I don't know what happened there. Okay, so you know how to solve things like 2 to the x plus 3 equals 16, right?
Yeah.
How do you solve that?
2 and 4. 2 to the 4.
Okay, speak full sentences. Don't just spout numbers at me. Make 16 2 to the 4th, okay?
And then you apply that.
Okay. Full sentences, right? We're grown-ups in high school here. And then, good, subtract 3, so we get x equals 1. Gentlemen, stop talking. Cole, put your calculator down. Now, how about we put it away, actually, so we won't be tempted to code while we're learning new stuff. Okay. So what we're going to learn today is how to solve some logarithmic equations. So basically, this is going to be when we have a log equal a log. Okay. For instance, if we have log base 5 of 5x plus 9 equals log base 5 of 6x. Just like with the exponential equations, if we have the same log on both sides, and it's just a single log on both sides, then we can set the other part equal. Okay. So this is when we just have one log on both sides of the equation, and the bases are the same. Okay. So then we can just simply solve this. X equals 9. Okay, so these are pretty simple.
So the logs just act as your bases?
Yeah, so because if you think about it, what's actually happening is we're saying 5 to the y equals 5x plus 9. And then we're saying 5 to the y equals 6x. Right? If I were to change each side into exponential form, right? We get 5 to the y equals 5x plus 9. We get 5 to the y equals 6x. Since both of them equal 5 to the y, they must be equal to each other. Does that make sense?
Would there be any logs with different
Yes.
log 3 equals log
That is
2?
entirely possible, yes. Okay. Okay, so let's do some more of these. How about log base 2 of 1 minus 4x equals log base 2 of 2x plus 43. Okay, what do we do? Okay, you're correct, but it's not the exponent, right?
So the numbers.
Right? It's really this simple. You add 4x and subtract 43. So x equals negative 7. Okay. Now, when we do this, we should also check it by pulling it back in again. Okay. So if x equals negative 7, we're going to get 1 plus 28, right? So we have log 29. And over here, we're going to get negative 14 plus 43, which is also 29. So we're good. Okay, so that one's fine. Okay, let's look at another one. Let's do log base 9 of 6 minus 3x equals log base 9 of negative 2w. Oops, sorry, x. Sorry about that. And again, just a reminder, this we can only solve like this if there's a single log on each side of the equation. If there's other logs over here, we cannot use this method. We're going to learn a different method for that. Okay? So you can only use this method when it's a single log on each side, right? When it's log equals log. Okay? All right, so we get 6 minus 3x equals negative 2x. So let's say adding 3x to both sides, we get 6 equals x. Okay? We're going to plug it back in just to check it. So this will give me log base 9 of, let's say, 6 minus 18 equals log base 9 of negative 12. So we get negative 12 over here, and we get negative 12 on the other side. Okay, this brings us to another issue. If I try to take the log of a negative number, I'm going to get an error. Okay, you cannot take the log of a negative number, right? So let's just do log base 10 of negative 100. Okay, we get an error, okay? You cannot take the log of a negative number. And if you think about it, this is saying 9 to what power equals negative 12. We can't raise that 9 to any power and make it a negative number. If I use a negative exponent, that's going to make it a fraction. If I use 0, of course, I get 1. There's nothing is going to make this a negative number. Okay? And you're not going to ever have a log of a negative base. So if you get a negative number, when you substitute back in, even though we got a positive 6 as an answer, when we substituted it back in, it forced it to be a log of a negative number, which means this is not a solution. So there is no solution. No solution. Okay. Okay, so on your homework number 6, or homework 6, I would like you to do numbers 1, 2, and 4. Actually, that's not true. Wait a minute. I've got to go through that a little bit better. So homework 6, you're going to do numbers 1, 2, 4, 7, 10, 11, 12, 13, 15, and 16. And then we'll go over it, and then we'll learn something new. Now, some of these are using things that you know from before. Okay, so you got to use your cabeza. Okay, first one, what did you do? So we have 3x minus 11 equals 25 minus x, and we end up with x equals 9, okay? So that was a nice, easy confidence booster one. Okay, number 2.
Is this N or H?
We get 4n minus 7 equals negative 3n, which ends up giving us n equals 1. But when we check it and we substitute the 1 back in, we get 4 log base 7 of 4 minus 7, which is log base 7 of negative 3. So we can stop right there. I don't have to even look at the other side. So since I have the log of a negative number, this doesn't work, so we have no solution. Cannot have the log of a negative number. Okay? Okay, let's see. Then we skip down to number 4. What do we do with number 4? Log of m squared equals log of 36. So m squared equals 36. So m equals plus or minus 6. But of course, we can't have a minus 6 because of that. So we get m equals 6. Good so far? Okay. Number 7. W squared plus 21 equals 10w. So what do we do to solve this? Right, it's quadratic. So we're going to move it over. So then we can factor this as w minus 7 times w minus 3. So w equals 7 or 3, and both of those are acceptable answers. So we're good. All right, now to the fun side. Dun, 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 dun. Number 10. So we're going to change this to log of x minus 3 squared equals log of 25. So we have x minus 3 squared equals 25. We have to FOIL this out. X squared minus 6x plus 9 equals 25. And then we'll subtract 25 from both sides. Okay. And this will factor as x minus 8, x plus 2. So x equals 8 or negative 2. It cannot be negative 2 because that would give me a negative log right here. Yeah.
When you get to x minus 3 squared equals 25,
Mm-hmm.
can you just square root them both? Then you get x equals 8. That's what I did.
Get x minus 3 equals 5.
Yes, you can. Be careful when you square root both sides. You're going to get x minus 3 equals plus or minus 5. So make sure you do x minus 3 equals 5 and x minus 3 equals negative 5. In this particular example, if you forgot to do the plus or minus, it would work out okay, but that's not always the case,
Okay.
right? Good observation. Okay, number 11. How do we do this one?
Switch the 2x minus 7.
Yeah.
So have
So
it
it'd be 3.
as
Good, yes. Put it in exponential form. Very good. Okay, 3 to the 4th is 81. Thank you. Okay, so we get 88 equals 2x, so x equals 44. Big number, but it's okay. It's perfectly fine. Okay. Okay, number 12. What are we going to do first on that one?
Minus the 15.
Good. So log base 8 of 28k minus 20 equals 3. And then we're going to put it in exponential form again.
I see.
So that we've got 8 to the third equals 28k minus 20. 8 to the third is 512. Add 20. So we get 532 divided by 28 equals k,
19.
which is 19. Thank you. There we go. Are we good? Okay, number 13. Now we have 9 to the 1/2 equals 15 minus 4n. What's 9 to the 1/2? 3. So we get negative 12 equals negative 4n. So n equals 3. We good? So they're not all exactly the same, so you do have to use a little bit of your thinking. Okay, here we're going to do log base 4 of k squared equals 4. So that means 4 to the 4th equals k squared. 4 to the 4th is 256. Square root of both sides, plus or minus 16. We can't use negative, so k equals 16. Okay, number 16, what are we going to do?
8 squared equals
Yes.
8 squared.
Good. So that's going to be 64. We'll subtract 15. So we get 49, which means p equals plus or minus 7. Can it be plus or minus 7?
Well, should we just?
Yeah, it can be actually, because negative 7 squared is going to give me a positive number. So it can be plus or minus. Okay. Yes.
Would 15 be plus or minus 9? And with the 2 would make it 16 squared.
That's a really good question. I'm going to look at that on the graph and see what it looks like. Because that's a little bit of a, I'm not 100% certain on that one. So let's look at it from another view. Okay, so we're going to do 2. I'm going to put it in the way the original problem is. Let me see. Where did we find the log on the math? Here we go. Okay, log base 4 of x. And we're looking to see where that equals 4. Now, I've already solved it and come up with 16 as an answer, so I'm going to change my window to go from like negative 25 to positive 25 so that I can see the point of intersection. Okay, so there's my point of intersection. So clearly we're only looking at one solution. Okay, so that's the reason the log does not go the other direction, so it's only going to be the positive one. Okay, very good question. Let me just, out of curiosity, I'm going to put in log base 4 of x squared and see if there's a difference. There shouldn't be, but let's just double check it. Log base 4 of x squared. Okay, so it's the green one. Oh, that's weird.
It's crazy.
So why wouldn't that be the case? I don't know why that is, why it doesn't do that. If we're bringing the 2 in front, I have to look that up. I'm not 100% certain on that one, and I would just be guessing, and I don't want to do that. So I will look that up, and but for now, do what I did and use your calculator to check it with the graph if you're not sure. Okay, so another type of log problem that you would see would be something where we have log equals a number. Okay. Log equals a number. So this is the other part that's not in your notes that I gave you. Okay. So for instance, right, you've already really done most of, oh, wait a minute. Yeah, I'm sorry. I don't want to give you that one. We've already done those. Hold on a second. Let's do, what happened there? I don't know why my computer screen keeps freezing here. Okay, let's look at this one. Let's look at log 2x plus log x minus 5 equals 2. What makes this one different than what we've been doing so far?
Logs on the same side.
There's more than one log on one of the sides, right? So can we change this so that it's just one log? Sure. Log 2x times x minus 5. Now we've got just one log on the side and a number on the other side. So what can we do from there? What's the base of this log? 10. So it's going to be 10 to the second equals what? 2x squared minus 10x. All right, so and we're going to subtract the 100 from both sides. So this time we can't just take the square root of both sides because we've got that minus 10x, right? All right, so we take a 2 out. Okay, so that's going to factor as x minus 10, x plus 5. So x equals 10 or negative 5. So if we look back at the original problem, make sure you go back to the original. We're looking at 10 or negative 5. So we can see because of this log here, the negative 5 will not work. So my answer is just 10. Make sure you go back to the original problem when you're checking it. Okay. Okay, let's look at this one. Let's do 2 log x minus log 4 equals 2. What do you think?
Put the square.
Yes. Move it up to the exponent. Then what?
You make the 4t squared.
Say again?
We divide it.
We're going to do the division first. X squared divided by 4. Okay.
And you do 10 to the power 2.
Good. Okay. Because there's no base there, so we assume it's a 10.
Oh. Then would you times it by 4?
Mm-hmm. So we get 400 equals x squared. Square root of 400 is plus or minus 20.
Square.
Mm-hmm.
Where'd you get this squared over the 10?
Because this is the base, so it's going to be 10 to the second power. Okay, so let's see, we get plus or minus 20. This is another one of those cases where if we look at the problem in this form, it seems like either would work, but since the original problem was in this form, we're going to say that the answer is only the positive 20. And if we graph it, we'd find that we had the same situation as the other one. Yep. Okay. Okay. Let me see. Any weird ones there? All right. So what I'd like you to do for homework then, and you can start now, is your homework 6. Basically all the other ones. So numbers 3, 5, 6, 8, 9, and 14. I'm going to do number 9. No, I don't want to do 9 with you. I'll do number 5 with you, okay? Number 5 with you. So we've got log base 4 of 108 minus log base 4 of 9 equals log base 4 of 7a minus 9. This is number 5 on your homework. What do you think we can do? Condense the left side. And now we're right back to the first type that we learned, where we've got the same log on both sides of the equation. So that means that 108 divided by 9 is equal to 7a minus 9. 108 divided by 9, so that's going to be 12, I think. Okay. Adding 9 to both sides, right, we get 21 equals 7a. So a equals 3. And that works just fine. And that's our answer. Okay? All right, when you finish, you're going to upload the entire thing to Google Classroom. Good, everybody have it copied? Okay.